Hello. So now in the previous video, I have explained how we get the misspecification bias if the exogeneity assumption is wrong in the classical linear regression model. It was simple. The derivation was pretty simple. Idea is simple. So we will generalize that case to the two regressors case. Here, now the difference is that we have two regressors, but we assume that only one causes the problem. So x1 has no problem. By the way, x1 has no problem. x1 is truly exogenous, but x2 is not. x2 is endogenous. Still, the problem is that you believe both are exogenous. So you could not tell the endogeneity, you could not detect the endogeneity of x2. Then the point here is, it is obvious that beta 2 is affected. So beta 2 will have some kind of misspecification bias. But our question is, what happens to beta 1? That is our main question in this model. To get to the point, simply speaking, the answer is very negative. So beta 1 is also biased. So it is very interesting. And so x1 is fine, but x2 causes the problem. Still, the problem is contaminates the coefficient of x1. So x1 is innocent, but it still have the same punishment. Let's see what's going on. So now we have two variables, and say x is just 2 by 1 vector, and beta, under the assumptions you believe, we derive that beta is identified this way. So beta equals to this if both variables are exogenous. But as you see, so remember how we derived it. So to see this, we replaced y with this form, this expression. So y is replaced by this form. And then if you expand it, we get beta plus something. And what we needed was this equals to 0. So expansion is simple. If you expand that formula, then you will get this, and we need this to be 0 for this equals to beta. Otherwise, this is the misspecification bias. Yes, this is the misspecification bias. And remember, this is 2 by 1, so 2 by 1 vector. So x prime is 2 by 2, and x epsilon is 2 by 1. Right? Because x is 2 by 1 vector. So this misspecification bias is also 2 by 1 vector, which means the first element of this bias is the bias for beta 1, and the second element of this bias is the bias for beta 2. We are going to derive each of them because it is possible, because this example is simply enough, because 2 by 2, so you can calculate the inverse of x prime by hand. So let's see. Now let's do the algebra. Expectation of x prime, I will denote the matrix in this way. So x11 can be understood as the variance of x1, or expectation of x1 squared, and x22 is the variance of x2, expectation of x2 squared. If you remember, if you interpret x1 and x2 as the demeaned variables, then you may interpret them as variances, and S12 is the covariance between x1 and x2. So S11, S12, S22 have natural, straightforward interpretations, and x times epsilon, the correlation, covariance between x and epsilon can be written in this way: element-wise covariances. So x1 is uncorrelated, but x2 is correlated. the covariance is rho, as we assumed earlier. Then just plug in these guys, and you get the misspecification bias of this form. So I believe that you can invert a 2x2 matrix. If you can't, you simply just search it on Google. It is simple algebra. I'm not going to show you the details, just I have learned it in high school, so do something if you don't understand what's going on. So anyhow, so you get this form, and now multiply matrix to a vector. Also, I believe that you can multiply a matrix to vector. Otherwise, it is a real big problem. As a result, you get this. So then it's a common. So the first denominator, it's a common constant, multiplied constant times something, and something is the. So this is for the first beta 1, and this is for beta 2. And first, let's think about beta 2. Misspecification bias for beta 2. Remember, beta 2 is the coefficient of the endogenous variable. So beta 2, it is easy to think that beta 2 is biased. Not a problem. Beta 2 takes this form. And as before, we can tell the sign of this. First, S11 is the variance of x1, so it is always positive. And denominator is always positive, non-negative, by the Cauchy-Schwarz inequality. So it is positive, so that means the misspecification bias for beta 2 equals to the sign of rho. So if x2 is positively correlated with the error term, then beta 2 will be overestimating the true beta. Otherwise, it will be underestimating the true beta. So the intuition is exactly the same. The only difference is the denominator is so this part is slightly different, and I believe there will be some chance to explain what this means later. But for now, I'm not going to explain why this part is more complicated. Later, we will get to this point. And now, so the main question is, what happens to beta 1? As you see, beta 1 also has some kind of misspecification bias. So, and the denominator is positive, and numerator is minus S12 rho. So, the sign of the bias is determined by two things. So S12 is the covariance between x1 and x2, which can be negative or positive, and rho is the covariance between x2 and epsilon. So you have two things at the same time, and let's think about this example. We are going to consider the same earnings, education, and ability example, but we additionally include age. So age is innocent. Age cannot be endogenous. It is exogenous. You cannot change your age at all. So then in this case, however, education is clearly endogenous. So if you do not have any instrumental variable, and if you use the classical linear regression model assumptions, your regression will be wrong. Then how wrong? Which direction is the bias? Then first, the coefficient of education is clearly on overestimating. So the bias of the coefficient of education will be positive by the same rationale I explained earlier. But what would happen to the coefficient of age? You need to think about two things. First, the covariance between education and intelligence is positive. So this is positive. This is positive, as I said. And second, what is this covariance, S12? So covariance between age and education. Then I would say it is negative because, so for example, compare your generation and your parents' generation. Like 20 years ago, the college entrance rate was much lower. So in that sense, older people have on average lower education. So the older a person is, the more likely the person is less educated. So in that sense, I would say this covariance is negative. So this is negative, this is positive, and with additional negative sign, the bias is also positive, right? So in that sense, we can conclude that beta 1 is overestimated. So even if we cannot estimate the exact value of beta through beta 1, but we can say that beta 1 is less than certain your estimator. Your estimator is above beta, which is still informative in some cases. That's what we can say. And then one more thing. Then it is possible that beta does not have any problem. Yes, this bias, this misspecification. So let's think about the misspecification bias for beta 2. For this misspecification bias to be 0, the only possible case is rho equals to 0. Variance of x1 cannot be 0. Denominator cannot be 0. So this is the only chance to be 0. This is the only variable that can be 0. So that means the misspecification bias always is non-zero, exists as long as x2 is endogenous. Obvious. Whenever it is endogenous, you have some problem, right? When rho equals to 0, that means x2 is exogenous, so it is obvious that beta 2 is correct. But now let's think about beta 1. There are two possibilities. Rho may be 0, which is obvious, so that's trivial. I'm not going to consider that case. But alternatively, if the covariance between x1 and x2 is 0, then beta 1 can be correct. That's what I'm saying here. If x1 is uncorrelated with x2, then beta 1 is unbiased. So, but such a case uncorrelated, so usually you can check it, you can calculate the correlation between x1 and x2, but almost always they will be correlated. So that means the endogeneity is a serious problem. When one of the regressors is endogenous, everything is wrong. So it's a big problem. That's why I spend a lot of time on this chapter. And it's a serious problem to almost any kind of economics applications. Okay, in the next video, I'm going to show you what happens when the exogeneity of an endogenous the exogeneity assumption for an instrument is wrong. So it will be interesting too. See you later.